All right, so we're going to talk about how to find a weighted mean, right? Sometimes our data counts more than some of our data counts more than others, right? You ask, how can that be? Well, your semester grades are calculated exactly that way, right? Your first 9 weeks grade is worth 40% of your semester grade. Your second 9 weeks grade is worth 40% of your semester grade, and your final exam grade is worth 20%, right? So to find your semester grade, your, let's say, 83% first 9 weeks, slacked off a little bit and got a 70% second 9 weeks, and you studied really hard and got a 90 on your final exam, right? So the first 2 9 weeks scores are going to count more. So sometimes we just want to weight some data points more than others, right? And how do we handle finding the mean for that, which is what your semester grade is? It is a mean of that weighted data set. Well, here's kind of a little formula, right? It can't just be a matter of adding up those 3 scores and dividing by 3 anymore, since some of them count more than others. So how do we do that? Well, we take each data point, we multiply it by its weight, okay? And then we do that for each data point, and then we add up all of those products. That sigma sign means sum, right? And then we take that sum and divide it by the sum of the weights. So if we're going to, say, calculate a grade, right? So Bobby's in his math class. In his math class, homework is worth 20%, tests are worth 80%, and he's trying to come up with his grade so far, right? Well, the first thing that Skyward does is it takes each category and calculates out a percentage for it, right? So we're going to need a homework grade first. So we got to find out what the percentage is of Bobby's homework grade, right? So we're going to basically add up the points that he got, divided by the total number of points. So 4 plus 6 plus 8 plus 9 divided by 10 plus 10 plus 10 plus 10, which gets us 27 divided by 40, right? And so 27 divided by 40 gets you 0.675. So he's got a D plus for his homework, right? Now for his tests, we got to add 89 plus 76 divided by the total number of points. So it's a percentage. So the total number of points for each test is 100. So 89 plus 76, which is 165, and divided by 200, which is 0.825. So a B minus for his test, okay? So it'll do that first, but the homework grade and the test grade are get weighted differently, right? So now that we have those percentages, we got to get into our weighted mean formula. So we got to take each data point, which is each percentage, 67.5, multiply by its weight, homework is 20%, and then add those 2 products, 82.5 times 0.8, and then we got to divide it by the total amount of weight. Now with scores like this, kind of interesting thing happens. So if we take 0.675 times 0.2, right, or we can take the percentages and do the same thing, but we get 0.135 plus 82.5 times 0.8 gives us a 66. Now 0.2 plus 0.8 is just 1. Now the sum of the weights is not always going to be 1. I mean, very often it should be, but not always. And so really it just becomes a matter of taking, we need to make this 0.66 and 0.135 and add them together. So we get 0.795 over 1, which is just 0.795 divided by 1, which is 79.5%. So you get a C+. Okay? So that's, if you know the weight for each data entry, then you use each data entry times its weight and then divide it by the total amount of the weights, right? And there you go. Okay, now, what if our data is grouped, right? Histograms do that, right? Where we'll show you, you're looking at a histogram and you still want to kind of come up with the mean, right? Well, we can do that. But if it's grouped data now, then everything's in classes, right? Histogram, everything's in classes. So what we're going to do is we're going to average out the class, find the class midpoint, which is here, multiply by the frequency, multiply by however many data points are in that class, and then divide by the number of data entries. And we should be able to figure out the number of data entries from a histogram. We may not know, and we have to use the class midpoint because we don't know exactly what each data entry is. If we didn't put the data in ourselves, then we don't have the actual data. We have to go by the histogram or that grouped data. Okay, so for example, I interviewed 21 students who worked over spring break, and I asked them how many hours did they work. Find the mean number of hours worked. Well, here's all we got, right? Whoever did this study created the histogram, gave us the histogram. And now our task is to find the mean number of hours worked. Okay? So, looks like one person worked between 5 and 10 hours. 2 people worked between 10 and 15. 4 between 15 and 20, right? And you can see all that broken down in the table right over here. Okay? Now, we don't have the exact answers to that survey. We don't have the exact hours that each person worked, but we can still come up with the mean, or at least estimate the mean. We won't maybe know exactly what it is, but we'll be able to estimate it pretty easily. So what we do is we got to find each class midpoint, right? Remember how to do that? We simply take the boundaries and average them. So this is going to be 15 divided by 2, or 7.5. Here, 15 plus 10 divided by 2, which is 25 divided by 2, which gets you 12.5. Okay? And you would continue all the way down, right? And I'll let you stop the video for a second, calculate those midpoints, then you can start the video back up and I'll show you what all those midpoints should be. Okay? And here they are. So 7.5, 12.5, 17.5, 22.5, 27.5, 32.5, and 37.5. So the frequency is how many data points were in each interval, right? So there was 4 data points in between 15 and 20. There were 6 in between 35 and 40. So what we're going to do is we're going to treat the frequency like weights, right? So this midpoint is going to get counted 6 times. Or we can multiply 37.5 times 6. So we're going to multiply these 2 columns together, right? So to find this mean, we've got to take 7.5 times 1, 12.5 times 2, 17.5 times 4, 22.5 times 0, but it's just going to give us 0, so we don't have to worry about that one. 27.5 times 3, 32.5 times 5, 37.5 times 6. And then we're going to divide that by the total number of data, right? So just add all these guys up. So that's 3, 7, 8, 9, 10, 15. Add those up and it becomes 21. There's 21 data entries. We just don't know exactly what those data entries are. So 7.5 times 1 is just 7.5. 12.5 times 2. 17.5 times 4. 27.5 times 3 plus 32.5 times 5 plus 37.5 times 6. And you get 572.5 and divide it by 21. So 27.3 would be an estimate, right? Okay? And that's it. Last two slides just walk you through those pieces individually. And that's it. If you have a histogram, right? That's just, it's because we don't have all the data entries. All right? But there's your mean of grouped or weighted data.